In this episode, we're going to do some lunar exploring. That's right, we're going to look at all things the moon. We'll discuss the lunar phases, various features on the moon, and how to observe them, as well as eclipses, supermoons, and lunar exploration. It's going to be a fun and interesting episode. If you're watching on YouTube, please like and hit that subscribe button. If you're listening on audio, please leave us a nice review on your podcast platform, as we really appreciate that. If you'd like to help support the Astro Guy podcast and YouTube channel, you can buy us a cup of coffee. The money is used to update and maintain the equipment that we use to publish and create each episode. The link is in the show notes. Thank you. We really love getting your questions, suggestions, and comments, and you can always leave us reviews as well. You can email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. Another reminder, we're going to be holding a contest as soon as we get to 1,000 subscribers on YouTube. So please tell your friends to check us out and subscribe. All right, let's get to the moon. Welcome to the Astro Guy podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the Astro Guy podcast. I'm your host, Wayne Zuhl. The moon, Earth's only natural satellite, has captivated human imagination since humans had imaginations, earning its place as an astronomical muse. Its phases, waxing and waning in a predictable dance, have served as a cosmic timekeeper for cultures across the globe. Astronomers throughout history have turned their gaze to the moon, unlocking secrets about our universe and the forces shaping our night sky. Beyond its beauty, the moon's influence on Earth's tides showcases the profound gravitational interplay between celestial bodies. Moreover, the moon's barren landscape preserves a history of cosmic collisions and solar system evolution, acting as a cosmic archive waiting to be deciphered. From ancient myths and cultural symbolism to serving as a platform for human exploration, the moon stands not only as our astronomical neighbor, but as a beacon of inspiration, guiding both scientific inquiry and the artistic musings of humanity. A while back, we had an episode featuring Michael Corvese discussing how the moon may have formed. It's a fun episode. I'll leave a link to it in the show notes. Okay, let's get into the phases of the moon. The moon's phases result from its changing position relative to the Earth and the Sun, creating varying amounts of the illuminated half of the moon that's visible to Earth. A lunar month, known as a synodic month, lasts about 29 and a half days and encompasses all the moon's phases. Here's an overview of the moon's phases and their progression. Day 0, new moon. The moon is positioned between the Earth and the Sun, and its dark side faces the Earth. The side illuminated by the Sun is entirely hidden from view, creating a seemingly invisible moon. This is the only time that solar eclipses are possible. Now we'll go into eclipses in a few minutes, so stay tuned. Days 1 through 7, waxing crescent. A small crescent-shaped sliver of moon becomes visible in the western sky just after sunset. Each night the crescent becomes larger and is higher in the sky at sunset. Days 7 to 8, first quarter moon. One half of the moon is now visible. The right side is illuminated, marking the moon's first quarter in its monthly journey. Days 8 through 14 are the waxing gibbous phase. This is when more than half, but less than the full moon, is visible. The illuminated portion continues to grow each day until day 14 or 15, when we reach full moon. So full moon occurs at days 14 to 15. The moon is directly opposite the sun, and its entire face is illuminated. The moon rises as the sun sets, and it's visible throughout the night. This is also the only time that lunar eclipses can occur. Again, more on eclipses shortly. Days 15 to 21 are when we experience a waning gibbous moon. The illuminated portion now begins to decrease, and it's now on the left side. The moon appears slightly less than full and rises later each day. Days 21 to 22 are last quarter phase. Now half the moon is visible, but now it's the left side that's illuminated. This marks the third quarter in the lunar cycle. Days 22 to 29 and a half are the waning crescent phase. Now a small crescent-shaped sliver becomes visible in the eastern sky before sunrise. The illuminated portion is decreasing or waning each day. At the end of the phase, day 29 and a half puts us right back where we were at the beginning. The moon is now once again in conjunction with the sun, and the cycle begins again. So why does the moon show these phases? Well, this rhythmic dance of illumination results from the changing angles and positions of the moon, earth, and sun during the lunar month. Observing the lunar phases provides a visual representation of the moon's orbit around our planet. I urge you to go out on each clear night and note the phase of the moon. Observe how it changes from night to night and its position. Take notes if you like. It's a fun experience. So now you know the moon's phases and you understand what causes them. Great. Observing the moon can be a fun and rewarding experience. Other than just observing it with the naked eye, what are the best ways to observe the moon? Here are some basics to help you become a better lunar observer. Binoculars are a great tool, especially when just starting out. Using 7 or 10 power binoculars will give you a wide field view of the moon, but you'll still be able to make out craters, mountains, and seas. Higher power binoculars will show more details, but you'll need to keep them steady. Using a tripod mount or image stabilizing binoculars will help tremendously. I'll leave links in the show notes to equipment that you may find useful. Viewing the moon through a telescope will reveal a tremendous amount of detail. You'll want to start at low power. Then, depending on observing conditions, you can boost the magnification to see features like mountain ranges, rills, and cliffs, domes, and faults, along with a myriad of craters and other features. The moon exhibits better contrast during the crescent phases than the gibbous phases, and we experience the worst contrast when the moon is full. Using a neutral density filter, especially between the first and third quarter phases, can help improve the contrast, especially when viewed through a telescope. I've even used various nebula filters when observing a bright moon. It helps with the contrast, but it also creates a colorful view. You'll find that the most interesting views will usually be along the terminator, the line between light and dark on the moon. There, the shadows are more pronounced, and you'll sometimes see high mountains and crater peaks illuminated just over the terminator on the dark side. This is always fun to see and makes observing the terminator a must when observing the moon. Using a lunar map will help you identify various features. There are great apps like Mobile Observatory that you can use on your phone to identify lots of lunar features. There's also a great free program called Virtual Moon Atlas. I believe they're now up to version 8. It's a great tool, and it provides great information about lots of different features on the moon. Using a tool like this will help you learn the names of many of the features that you observe. If you're good at sketching, that can be a useful tool to aid in your observing. I can't draw, at least not anything that looks realistic, but if you have a cell phone mount or another way to mount a camera to your scope, you can use that to take images of the moon. When observing the moon along the terminator, you'll notice that over time you can actually see more than 50% of the moon. This is due to the moon having a slight rocking motion that's called libration. Because of libration, about 59% of the moon's surface is visible over time to us. Observing the moon from an area with fewer lights will help you to see details better than from light-polluted areas. Visually, the contrast will be better from a darker location. Once you've familiarized yourself with observing the moon, you'll want to explore features like some of the larger, brighter craters like Tycho, Copernicus, and Clavius. The mare are darker areas called seas that are actually lava beds. Spotting them and then exploring the features of them can be a lot of fun. Mountain ranges like the Apennine Mountains can provide hours of enjoyment examining the features that are there. The moon is an integral part of both lunar and solar eclipses. Let's explore lunar eclipses first. A lunar eclipse occurs when the Earth passes between the Sun and the Moon, with the Earth casting its shadow on the Moon. There are three types of lunar eclipses: total, partial, and penumbral. A total lunar eclipse occurs when the central, darkest part of the Earth's shadow, called the umbra, completely covers the Moon. During a total lunar eclipse, the Moon often takes on a reddish hue and is sometimes called a blood moon. This is due to the Earth's atmosphere scattering sunlight and allowing the longer red wavelengths to reach the Moon. During an eclipse, the Moon's color can vary depending on pollutants in the Earth's atmosphere as well. In 1991, during a total lunar eclipse shortly after the eruption of Mount Pinatubo in the Philippines, we saw the Moon appear almost completely black. Normally, the color appears more red to copper during the total phase. A partial lunar eclipse occurs when only a portion of the Moon enters the umbra. The Moon tends to have a darker appearance in the area covered by the umbra. Watching this in a telescope, you can see the shadow slowly moving across the face of the Moon. A penumbral lunar eclipse is much more subtle, as the outer portion of the Earth's shadow, called the penumbra, casts its shadow, but it's far less noticeable than the umbral shadow. Visually, it can be difficult to even notice any change during a penumbral eclipse. Lunar eclipses are completely safe to observe with the naked eye or with any optical aid. Now, solar eclipses are a totally different animal. A solar eclipse occurs when the Moon passes between the Earth and the Sun, blocking all or part of the Sun's light. There are three types of solar eclipses: total, partial, and annular solar eclipses. During a total solar eclipse, the Moon appears to completely cover the Sun, and only the solar corona becomes visible. You must use a safe solar filter when observing the partial phase of any solar eclipse. During totality, you can safely observe the corona with the naked eye. You'll experience what looks like a sunset, except it will appear all around you, like a 360-degree sunset. You'll also notice that the temperature will drop, and animals like birds or horses will return to their nests thinking it's night. Total solar eclipses are relatively rare and can only be seen along a narrow path on the Earth. However, there will be a total solar eclipse that will be visible along a line from Texas to Maine on April 8th, 2024, so make your travel plans now. A partial solar eclipse occurs when the Moon only covers a portion of the Sun, creating a crescent-shaped sun in our sky. This can be easily and cheaply observed using a pinhole projector. We'll put a link to a site to show you how to make one in the show notes. Partial solar eclipses can be seen over a much wider area than a total solar eclipse, but you must use a solar filter when looking directly at a partial solar eclipse or an uneclipsed sun. An annular solar eclipse occurs when the Moon is too far from the Earth in its orbit to completely cover the Sun's disk. This results in a ring of sunlight, or an annulus, around the edges of the Moon. Again, solar eclipses require proper eye protection to observe safely. Viewing the Sun directly without proper precautions can cause serious eye damage or even permanent blindness, so please be careful. Both lunar and solar eclipses are phenomena that have fascinated humans for centuries. They offer opportunities for scientific observation and public engagement with astronomy. The alignment of the Earth, Moon, and Sun in precise configurations leads to these captivating events, reminding us of the dynamic relationships within our solar system. Now, you may have heard of a supermoon. Well, a supermoon is a term used to describe a full moon that appears larger and brighter in the sky than an average full moon. This phenomenon occurs when the full moon coincides with the moon's closest approach to Earth in its elliptical orbit. The moon's orbit around the Earth is not a perfect circle, but an ellipse, and its distance to Earth varies during its orbit. As we said, during a supermoon, the moon appears larger and brighter in the sky compared to a regular full moon. This is due to its proximity to Earth, making it look about 14% larger and about 30% brighter than when it's at its farthest point, or apogee. While the difference in size may be noticeable to keen observers, the visual impact of a supermoon is often more pronounced when the moon is near the horizon. This is known as the moon illusion, and it occurs when the moon appears larger when it's observed closer to objects on the horizon. Supermoons are not extremely rare and happen several times a year. However, the term has gained popularity in recent years as it captures the public interest in celestial events, and it makes for good clickbait. The term supermoon is not an official astronomical designation, but rather a popular term used in media and public discourse. Astronomers often refer to the phenomenon as a perigee syzygy of the Earth-Moon-Sun system. Since humans first looked up at the moon, it was an item of mystery. Over the last several hundred years, with the advent of the telescope, we've been able to observe it in great detail. But even the largest telescopes could only resolve details as small as about a mile across. Once the space age started, the moon was in our sights to examine more closely. In 1959, the Soviet Union crashed their Luna 2 probe onto the moon. It wasn't until 1966 when Luna 9 became the first craft to successfully land on the moon. This was the first time that humans, or in this case, a robotic lander, had made a presence on the moon. From 1969 to 1972, NASA successfully landed Apollo astronauts on the moon 6 times. Since 1972, however, the only missions to the moon have been robotic landers, orbiters, and rovers. Currently, NASA is working on the Artemis program to return humans to the surface of the moon. The next launch, Artemis 2, is scheduled to take place next year. It's going to be very exciting. Artemis 2 will see astronauts orbit the moon and return to Earth safely. Artemis 3 is scheduled to be the first landing on the moon, and that's likely to take place around 2027 or later. But why even go to the moon? Lunar exploration is important as it contributes valuable insights to our understanding of the moon, the solar system, and even our home here on Earth. By studying the moon, we get a glimpse into the early history and evolution of our solar system. Lunar rocks and soil act as time capsules, preserving information about the processes that shape the moon and, by extension, other rocky bodies in the solar system, like Earth. The moon's geological history is intertwined with the Earth's, and studying the moon helps us understand our own planet's past. Comparative studies of Earth and the moon can provide clues about the processes that shaped both bodies. The moon's lack of an atmosphere and its geologically inactive nature make it a pristine laboratory for studying space weathering, impact cratering, and other cosmic processes. By understanding these processes on the moon, we can apply similar principles to other bodies in the solar system. The moon is believed to contain valuable resources such as water ice and permanently shadowed craters. Extracting and using these resources could support future human missions by providing weather for life support and hydrogen and oxygen for rocket fuel. Lunar exploration drives technological innovation, pushing the boundaries of what is possible in space exploration. Developing different techniques for lunar missions leads to advancements that have broader applications in space exploration and many other fields. Another reason for humans exploring the moon is that the moon serves as a stepping stone for human exploration beyond Earth. By establishing a sustainable human presence on the moon, it can act as a testing ground for technologies and systems needed for future missions to Mars and beyond. Besides observation and exploration, the moon has had a significant cultural impact for humans that spans across centuries and touches many aspects of human civilization. The moon holds a central place in mythology and symbolism across many cultures. In ancient mythology, lunar deities often represented femininity, fertility, and the cycle of life. Examples include Artemis in Greek mythology and Chang'e in Chinese mythology. The changing phases of the moon have also been linked to the cycle of life, death, and rebirth. Many cultures have based their calendars on the lunar cycle. The Islamic, as well as the Jewish calendar, are lunar calendars, and several traditional East Asian calendars follow the lunar phases. The moon's regular cycle provided an early and reliable method for timekeeping, influencing cultural and agricultural practices, as well as religious observances. For example, Easter Sunday always occurs on the first Sunday after the first full moon that occurs on or after the vernal equinox. The moon is also an important figure in art and literature. It has inspired countless works of art, literature, and poetry. Many artists depict the moon in their paintings, capturing its ethereal beauty. In literature, the moon often serves as a metaphor for mystery, romance, and the unattainable. Shakespeare's Romeo and Juliet are a classic example. There is much folklore surrounding the moon. Tales of werewolves and lunar eclipses being harbingers or omens. Cultural superstitions often associate lunar events with mysterious happenings and transformations. These stories have contributed to the mystique and intrigue that is associated with our moon. Many ancient cultures, such as the Babylonians and Mayans, had sophisticated astronomical knowledge, and the moon played a crucial role in their celestial observations. They created temples and structures aligned with lunar events. This underscores the cultural significance of the moon as a celestial marker. Many religious traditions incorporate lunar cycles into their observances. The Islamic calendar, as mentioned earlier, is lunar-based, and the timing of certain religious festivals are determined by the phases of the moon. In Hinduism, the festival of Karva Chauth involves fasting and praying for the well-being of one's spouse. It is based on the moon's visibility. The moon plays a part in pop culture as well. When Neil Armstrong uttered the iconic words, "That's one small step for man, one giant leap for mankind," he left an indelible mark on popular culture. The Apollo landing symbolized human achievement and exploration. The moon continues to capture the imagination of popular culture through science fiction, music, and films, such as 2001: A Space Odyssey and First Man, and many others. The moon's cultural impact is multifaceted, weaving through mythology, timekeeping, art, literature, folklore, religion, along with current space exploration and its place in popular culture. The moon's enduring influence reflects the universal aspects of the human experience and the many ways in which different cultures have interpreted and celebrated the celestial body that lights up our night sky. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zuhl, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.